Today I want to talk about the relationship between centripetal force and the radius, or to say the distance from the object that's traveling in a circle and the center of that circle. So if we can see this disk right here, let's assume that this disk is like rotating around and around. We have this little pebble. It's very close to the center. That's A. This pebble is much further away, that's B. And so there are the radius, the distance away from the center, they're different. And so sometimes they will ask in questions which ball falls off first. And you might think that it would be A, because we know that F equals mv squared divided by r. So if r is smaller and F is fixed, then V surely must become higher, right? Which means that using the same force, A can hold on for here until it's at a higher speed and B cannot. However, this is wrong. B is going to fall off first. And that is this sort of confusion that happens, well, it definitely happened to me with the two equations. And so when we talk about centripetal force equations, we have two of them, right? So we have F is mv squared divided by r, and then we have F is m omega squared times r. And the thing about this that is not always specified is that, for example, when we are using this equation, and we can derive these equations from each other, right? This is assuming that the omega or the omega or the angular velocity is remaining the same. So what does that mean? Well, basically there's no omega in this equation, so we have to assume that it stays the same. It's not a variable in it. So if omega is fixed and r becomes bigger, that means it is still going to go through the same amount of rotations per second, because the angular velocity is remaining the same. However, when r becomes bigger, 2 pi r, the circumference also does. So, because omega is the same and the angular velocity is the same, only the distance that it travels is increasing, that means that the velocity will increase, because the velocity is the distance divided by time. Assuming that the distance for one revolution, the time taken for one revolution, is the same, and it's going to be the same because of the angular velocity remaining the same. That means that time is going to be fixed because of the angular velocity being fixed. However, the distance traveled is going to go up because we have seen before that 2 pi r has gone up, which means velocity will increase. So the increase in velocity, and this is a v, it will dominate the increase in the radius because v is squared. So this basically means that the bigger the radius, the bigger the velocity. And actually the increase in the velocity is much bigger than the increase in the radius. So in conclusion, the force will increase. So what we have concluded here is that when radius becomes bigger, velocity will also become bigger if omega is fixed. We have another equation, as we've seen, and that is F is m omega squared r. And so for this equation, we don't have the velocity in here. We don't have the speed in here. So we have to say that the speed remains the same. It is a fixed variable because it's not part of the equation. So when r increases, when the radius increases, 2 pi r will also increase. However, because the velocity remains the same, it's traveling at the same speed, it means that omega has to decrease. Why is this so? Well, if it's traveling at the same speed, let's say it's traveling like this, then when it's smaller, omega will increase. The amount of revolutions per second, the angle that it travels through per second, it will increase. But if it travels through a bigger circle, the speed is the same, but the time taken for one revolution is much more, and therefore angular velocity will decrease. And the decrease in the angular velocity will dominate the change in r because omega is squared, and therefore force decreases, which means that when r increases and the velocity, or the speed, speed, is fixed, that means that the angular velocity will go down and the force will go down. So ultimately it's pretty confusing, but it all depends on which variable you want to fix in that situation. So over here it says, according to the double equations, the closer you are to the center, the less force required, the less force it is required to give you an even higher velocity. And that is indicated by this equation, not by this one. However, the alternative is true when we're talking about this equation and not this one. So as I said, it's just very much dependent on like which variable you want to fix. Look at the equation that you are using in that question or situation or anything, because whatever that is missing from that equation is going to be the fixed variable. So finally, I'd like to conclude by giving you these two equations. So these are the two equations for centripetal, acceleration, force, whatever it is. Oh no, did that wrong. Right, so these are the two equations, right? Well, now we can conclude that when you are using this equation, then we have to say omega is fixed, so the angular velocity is fixed. So that means as r increases, velocity will also increase. So r is actually going to be directly proportional to force. And that's because an increase in r will give rise to an increase in velocity, and this will become bigger than that, so the force will ultimately go up. For this equation right here, we can say that r is inversely proportional to the force, the centripetal force. And that's because as r goes up and v is fixed, so the speed is fixed, that means the angular velocity will have to go way down because it is traveling at the same speed. And this will dominate the increase in r. It will overall go down, and therefore the higher the r, the lower the force for this equation. So it really depends on what you fix, and that's not that complicated.